Hello and welcome. In this video, we will look at the Virtual HIL analog and digital IO Loopback feature, available with the 2022.1 release of V-HIL Control Center. In prior software versions, digital and analog IOs were only accessible when using an actual HIL device, meaning that you would need to update your model and IO settings when switching between simulations in Virtual HIL, or V-HIL, and simulations with real controller hardware in the loop, or C-HIL. Now, by enabling Virtual HIL analog and digital IO Loopback, all digital and analog outputs loop back to their respective inputs. In this way, you can improve your model continuity when going from software in the loop testing scenarios to controller hardware in the loop verification and validations. To demonstrate that, let's go to Examples Explorer and open the example called Induction Machine with Closed Loop Control. Notice that the speed controller is implemented within the model, using signal processing components. Then, from the reference signals, the three-phase inverter is controlled using the internal modulator control type. Notice also that a tag is used to directly feedback the mechanical speed of the machine to the controller. Let's now open a modified version of this model created to demonstrate Virtual HIL analog and digital IO Loopback. This feature can be enabled or disabled in the model settings using the corresponding checkbox. This feature is not enabled by default in order to optimize V-HIL simulation time in case you don't need to use it. In this modified model, the PWM modulator is implemented externally using a dedicated component in order to demonstrate the loopback of digital outputs. The outputs of this component are available in the digital signal map and can be individually routed in the SCADA panel to any of the digital outputs. To better show this, let's open the SCADA panel created for this demonstration and run the simulation in Virtual HIL mode. In Model Settings, you can see that we selected digital outputs 1 to 6 as the output signals from the PWM modulator. If V-HIL analog digital IO Loopback is enabled, these digital outputs will be available in the model as digital inputs of the same number. You can directly select them to drive the converter using an appropriate control type, such as digital input per switch. In this model, the enable signal is also added to the digital signals list using a digital probe, and the corresponding output is then looped back to the model using a digital input component. The digital input index is selected here as 7, matching the digital output assigned for this signal in the model settings of the SCADA panel. Finally, let's demonstrate the loopback of analog outputs. Instead of using a direct feedback of the mechanical speed to the controller as in the original model, let's now configure the machine mechanical speed measurement as analog output 1 on HIL SCADA and set the scaling and offset. This configuration can be defined considering a future interface with an external controller. In the model, you can now use an analog input component to loop back the signal, selecting the appropriate index, offset, and gain. Let's go back to the SCADA panel and change the speed reference from 1200 RPM to 800 RPM. As we can see, the V-HIL simulation with loopback of the IOs provides the expected responses, even though it is not running in real time. In this tutorial we showed how, from the 2022.1 V-HIL software release, you can loop back analog and digital IOs in V-HIL simulations. By using this feature, you can seamlessly transition from V-HIL testing scenarios to C-HIL real-time simulations, avoiding the need to change IO settings, the power stage model, or the interface of its components. Thank you for watching.